There's no easy way to add and subtract complex numbers when they're in cis form. So what you have to do first of all is to convert back to Cartesian form. And remember that when you're talking cis form, you've got cis theta equals cos theta plus I sine theta. So we're going to use that to re-express both of these complex numbers. So 2 cis of pi on theta equals 2, and we've got, I'm going to do a big bracket there, cos of the angle plus I sine of the angle, which is pi on 3. So what you need to do here is, use your standard triangles and remember that you've got, this happening, pi on 3 and pi on 6. And you've got here 2 cos of pi on 3. I always just draw myself a quick picture as well, just at the side, so I know cos and sine will both be positive here. So cos of pi on 3 will be a half, sine of pi on 3 will be root 3 on 2. And that's multiplied by I, because remember that the part with sine is the imaginary part. Now if we multiply this out, you're going to find the 2's actually cancel out everywhere. So that means that our complex number 2 cis theta, 2 cis pi on 3, I should say, is 1 plus I root 3. So that's in the Cartesian form. So do the next one. You could do this one, stop the video and do this one yourself. See if you can do it. So again, I'm just using this format 3, and the cis is cos of the angle plus I sine of the angle. And just my quick sketch in the corner, 2 pi on 3 is over here. So I know that the cosine is going to be a negative. The sine will be positive. So I'm going to write that out as 3 cos of pi on 3. Remember that cos of pi on 3 is a half, but this time it will be negative a half. And for sine, it's root 3 on 2. This one won't cancel out as nicely, so I'm actually going to end up with a fairly ugly looking 3 root 3 on 2 there. So 3 cis 2 pi on 3 is equal to negative 3 on 2 plus root 3 on 3, 3 root 3 on 2i. Okay, so now what I'm going to do is actually combine these and add them, because they're in the form that I can work with now. So 2 cis of pi on 3 plus 3 cis 2 pi on 3 equals the first one written in Cartesian form. I'm actually going to put the I second now, just because we've worked with it that way in Cartesian form. Plus, I'm going to add all of this as well. 3 root 3 on 2i. So if we add all of those together, what you're going to find is that here with 1 minus 1.5, you're going to end up with minus a half. Okay, so, and as you're going, it's a good idea to, cross things off. And with these ones here, you've got 1.5 lots of root 3 plus 1 root 3. So that would be 2.5 lots of root 3, okay? Or as a fraction, improper fraction, you're going to have 5 on 2 root 3. So all we've done is combine these together, okay, I. So that's your answer. So when you're working with subtracting and adding complex numbers that are in cis form, the most important thing, which I've put up here in red, is that you need to make sure that you convert first, go to Cartesian form, and then once you're in Cartesian form, you're just doing your adding and subtracting as normal. Remember to use this identity here for what cis is, cos theta plus I sine theta.